Okay, if we want to implement the multi-color system, because we can mitigate fading and we can provide high data rate, we can use in a sense a relatively advanced DSP hardware or algorithms in essence. The main point here is that when we are using multi-carrier basis functions, as we said, we can put them in their complex exponential form, right? We don't use cosines and sines, we can use the complex exponential, right? So here at the transmitter side, what we do is that we take the symbol multiplied by the channel pulse, and then we multiply it by a subcarrier basis function, and we do this thing for all the subcarriers, right? Of course we can scale them. Of course, if we have a rectangular pulse for simplicity, this is the shape that we will get here, right? It's very simple. um, Recall that this form, the, the previous form, is actually, it is the inverse discrete Fourier transform. So here this is inverse discrete Fourier transform. So a multi-carrier transmission system is actually the IDFT. So instead of using all this modulation subcarriers, we take the pulses, the symbols, and we perform IDFT on them, and this will give us our multi-carrier transmitted signal, right? So of course here the xi's are the SNs here, or which are the complex QAM symbols. Recall that we can represent the QPSK and the QAM symbols with a complex value. So the real part is the in-phase component, and the imaginary part is the quadrature component, right? Similarly, at the receiver, we use the DFT. Of course, the way that we implement DFT is using the fast Fourier transform, and IDFT is the inverse fast Fourier transform. So how do we do the implementation in the transmitter? We get the bits, we do the modulation here, so we convert them from bits to complex values. X here is complex, right? Because we've done the QAM modulation. Recall the BPSK is a special case of the QAM, right? So then we convert from serial to parallel, and now we feed them to the inverse fast Fourier transform. We add a cyclic prefix. We'll discuss this thing in a bit. Then we convert them to analog. So all this part is done in a digital format, meaning we can program them, right? And here we up convert them, or we modulate them to the carrier frequency. At the receiver, we perform the inverse, right? We demodulate them here. Of course, when we do demodulation, we are producing high frequency content, so we need to use a low pass filter. Then we convert them into digital signals, convert them from serial to parallel, take the FFT, which is the inverse of the inverse FFT, and then convert them from parallel to serial, do the demodulation on each symbol alone,